Hey everybody, home live stream. I am Mr. C as always, and I'm coming to you live from Cambridge. This week we have a special guest co-host with me. Everyone say hi to Beck. How's it going, Beck?
Hi Mark, it's great to be here. I'm Rebecca and I am a learning manager at the Raspberry Pi Foundation. I write cool lessons for computing teachers to use in their classrooms, and I also record online lessons for students too.
Awesome. So you've been in front of the camera a couple of times and you'll be comfortable enough so you know what's going on. It should be fine.
Fingers crossed.
Yeah. I'm loving your wallpaper, by the way. Every time I see your videos, I think that is some amazing wallpaper.
Yeah, it is my favourite. It was one of those things like non-negotiable. We're having this wallpaper.
Awesome.
And it happens, so I love it.
Yeah, no, it's wicked. So for those of you people who are joining us for the first time this week, Digital Making at Home is all about getting young people like you coding, making awesome stuff with tech and getting excited about doing great things. So every week we chat with amazing people, we code together, we see amazing digital making products from other young people like you. And so this week we're broadcasting to YouTube, Facebook, Twitch and Twitter right now. We can see your comments, so please chime in if you have any questions about things you'd like to you've heard on the stream today, or anything that you want to get in touch with us about. Dump them in the chat and we'll have a talk to you over the course of the stream. So remember to hit that subscribe button on YouTube as well to get the updates from us, to make sure you know when we're going live and when we're putting new content on the channel. So should we jump into it, Beck?
Yeah, and I am excited to be hosting this week's stream with you because we are talking with a special guest this week who's going to come on and do some Python with us using the awesome SenseHat emulator. And I absolutely love using a SenseHat, so this is going to be a really good one. You guys know Carrie Anne, right? I hope. She's been on the stream before, and she's got her own YouTube channel and everything.
Yeah, no, she had a great chat with us last time she was on about how she got involved in computer science and how she's done all these amazing things for young people with education. So let's bring her on. Let's get her on the show right now. Carrie Anne, how are you?
Hi. I'm super excited to be here. Thanks for having me. How are you?
Yeah, great. I'm really good. Like, it's a bit chilly in my house at the minute, but I got my jumper on, so.
I know, right? I'm in Cambridge too, so I know exactly how you feel. Winter
totally,
is
Definitely. So, I mean, how are you generally speaking? Like, it seems like it's been a while since we've seen you. Like, what's been going on?
Just busy. You know, still trying to push that mission all the time to help get young people into computing and digital making so that they can, you know, make the future a much better and more amazing place using technology.
Yeah, I mean, I think, so some people who are watching this week may not have seen our previous amazing episode where you were on. So could you tell us a bit again about sort of how you got involved in digital making and how you did that coming from a BA in humanities? Like, I myself have a BA in humanities. I'm also here doing amazing things with tech, but how did you get there?
So I think you and I, Mark, are of a generation where when we were growing up, computers were around, but they weren't always something that was kind of immediate, you know, an industry that you could go into. Unlike now and the kind of future that we're looking at, where computers are everywhere and technology is everywhere. So I think, you know, I just did the subjects that I was good at, and I'm a very creative person. I think you're going to see that in a minute when we get down to it and we start doing some digital making. And so, you know, I like to marry my interest in creativity and art and making with my love for problem solving and pattern recognition and generally, you know, my mathsy STEM side. You know, digital making is a great way of bringing those two things together, and it's just a passion.
Awesome. That's really cool. I'm seeing loads of people are tuning in from all over the world today. We've got people from Tunisia, from Venezuela. Hey, out there. We've got Ali coming in from Iraq again. Nice to see you, Ali. How's it going, mate? So people that like all the stuff that we're talking about here, it's a universal thing as well. And I think that's one of the things that I love the most about it. And like, I mean, no matter what you're doing, what sort of things you're knocking together or making, someone else in the world who doesn't speak your language can see that and look at it and be inspired and make something awesome as well. I mean,
but also you get to solve problems that are meaningful to you wherever you are in the world, right? And that's absolutely super powerful.
Yeah, that's really cool. And like, have you been making anything lately?
So, well, I've been doing fun things with my team. So recently we had Halloween, so we were flashing some LEDs connected to our Raspberry Pis. That was kind of fun. Mostly at the moment in my free time, I'm doing lots of sewing, getting ready for the holidays, making lots of gifts for my family. And work-wise, you know, I'm super lucky to work with such an amazing team. We have been full on recording computing lessons so that young people can access a lesson as if they were in a classroom, but remotely from home, using the expertise we have within the foundation. So Rebecca is one of our teachers who does an amazing job on that. So anyone, wherever you are around the world, head to Oak National Academy. If you're interested in computing, you can access those lessons completely for free.
That's super cool. So like Oak National Academy, like I know it's a thing and I vaguely understand about it, but what sort of work are we doing to get computer science lessons available to everybody?
So in England, we're very fortunate. We have a computing curriculum, and it's really been invested in by our government really recently. And we've been very fortunate enough to be the foundation that has produced 500 hours worth of lessons to be able to teach the subject really well and really deeply, and using all of our experience in digital making to really bring that curriculum to life. And that's all the way from age 5 through to 16. And this, due to the pandemic, we've obviously, like a lot of places around the world, our schools have closed, and so children haven't had access to their teachers and their computing lessons. So we've been really fortunate. We've partnered with Oak National Academy, who built, an infrastructure, a web site that helped deliver just lessons, general maths, English, science lessons to help children who were studying from home. And they partnered with us so that we could adapt those lessons we had written for the classroom into computing lessons, video lessons, which was a really interesting thing to do, and we're still learning from that. And we're starting to really see the impact of those lessons now. And the best part is although they're designed for children in England, obviously the first language is English, but if you can speak English and wherever you are in the world, you can access those completely for free.
That's super cool. And that's what you've been working on, isn't it, Beck? That's what you've been putting together.
Yes, it was a lot of filming, a lot of sitting in this room here and just talking to camera to nobody for a long time. So it's quite nice at the moment seeing all these people tuning in and actually getting some feedback, which is just lovely. It's great to see. I've been waiting for this from John Gunner. That's a nice comment there. It's really, really lovely to see all of those messages coming through.
Yeah, that's awesome. And so I also understand, Carrie Anne, that you were recently honoured with the Most Bestest Educationer Award. Is that right?
That's definitely what it's called. And I look forward to whichever member of the royal family bestows this award on me, that they use that terminology.
Yeah. So can you tell the international audience what it actually is that you were awarded? Because it wasn't Most Bestest Educationer, was it? It was.
No. So in the UK, we have something called the honours system, and so citizens of the country who do good work are recognised through the honours system. So I have been awarded a member of the Order of the British Empire, which, I'm sure, Mark, you are from Australia, so from the colonies, I'm sure that terminology doesn't super excite you, but, it's just a fancy way of saying that the work that I have done is being recognised. And although that's super nice and great to be recognised personally, really, none of these things are a solo effort. Nothing I've ever done has been a solo pursuit. And so really this award is for all the people that I work alongside and with, who have worked to really push computing education here in the UK. But I hope that the work I do here has an impact around the world.
Absolutely, it does. We're getting comments coming in, people saying thank you for your videos on Crash Course Computer Science, all those sorts of things. It's very magnanimous of you to share your award with the team. But to be honest, Carrie Anne, you've done unbelievable work. I think it's ever since ever. Like I remember hearing about you years and years ago and being inspired by you. So don't sell yourself short. It's amazing. So now that you have an MBE, like you're a member of the British Empire, is that right? Member of the British Empire?
Member of the Order of the British Empire.
Member of the Order of the British Empire. So like, do you get like a cool hat or like a sword or something? Do you have to defend the realm?
That's cool. That's pretty cool.
If a dragon shows up, do you have to fight it?
Definitely. Yeah.
Amazing. That's really cool. And do you get like discounts at Burger King or on your taxes or anything like that for being a member of the Empire?
Do you know what? I really need to look more into this now that you say that.
You might do. You got to look into that. There might be like a punch card, right? Like,
I think I can get married in St. Paul's Cathedral, which is a big church. It's actually where Princess Diana and Prince Charles got married. I think I'm allowed to get married there, but the problem is I'm already married. So. Yeah.
That's pretty cool. That's actually a pretty cool benefit of it. Like, who knows? You should definitely look into the perks system around the MBE. There might be something that you haven't heard of, like, who knows? Could be really cool. Anyway, should we do some coding?
Let's get on with it. Let's make some things.
Yeah. So
really good fun.
So what are we doing today? What's the plan? I know we're going to animate a pixel pet. We're going to use the Sense hat, which I love. But tell me all about it. Okay.
Well, I mean, I don't know about you, but when I was younger, I mean, and this is where I really show my age, but there were and for the young people watching, this may not resonate at all. But when we were little, there was this little toy that came out, and it was called a Tamagotchi, and it came out of Japan, hence the name Tamagotchi. And it was a kind of virtual pet that you had to look after. It was on a keychain, and you would take it around, and it would need feeding, and it would need taken for walks, and it would, do its business, and you had to clean up after it. And I was really proud because I kept mine alive for a really long time, which when you're a kid is super important. And when the Sense hat came along, people were doing really cool stuff, lots of sciencey stuff with it. But my first thought was, oh, hey, it's got some flashy lights. I could turn this into my own virtual pet, my own Tamagotchi. So that's what I thought I would show you what we could do with it.
That's amazing. I love it. This highly scientific piece of equipment, and like we're building a Tamagotchi out of it. I love that. I'm all for that. Like I love doing that sort of thing. That's so cool. We've got comments from Alan coming in saying that he's still got 3 of the original Tamagotchis. They must be worth some money by now, surely. Original Tamagotchi.
Oh my gosh, I wish I still had a Tamagotchi.
I killed mine, sorry.
I'm so proud of myself.
Cool.
Let's get started. Let's get on with it, right? Okay. So what you will need is some squared paper. So this is just some paper with some squares on. If you don't have any paper, you can, and you've got your computer open at the moment, if you have any spreadsheet kind of software, you could use that too. Just make yourself some smaller squares. That would work as well, right? Because what we're going to do is we're going to do a bit of colouring in before we get started. Because the first step in making your own virtual pet is to design what your virtual pet is going to look like. And if you can see on my square paper, what I've done is I have drawn here 2 boxes. And so I've got 8 cells down and 8 cells across that way. And I've created a square around it. And the reason for that is on the Sense hat, there are only 16 pixels. So that's what we're going to do. Look at Mark's. Mark's is great. Okay. What we're going to do, we need 2 different ones because we're going to want to animate our pet, right? So the first step is we need to draw our pet. And I have some colour pencils. I've only selected 3 colour pencils. Now, you can have as many colours as you want, but you're going to have to program them in a minute. So for this demonstration, I'm just going to use 3 so I don't have too many. And I'm just going to switch to my own little camera that I have here. Hopefully you can see this. There we go. Thank you, my hand cam. So you can see what I'm going to do. So I need a little face, I think, for my pet. So I'm just going to colour that in, and that one, and that one. Just as I kind of design my little pet. I think I'll give it a nose. Hopefully you can see. Give it a nose. I think you could probably do some legs. Go have some body, I think, to it. Give it another leg, why not? There we go. And I know what you're thinking, Mark and Becky, because you are complete overachievers, is that you're going to, really delicately colour in all of these cells and make sure that they're all coloured in nicely. There are no marks for how well you colour this in. So at the moment, this is just for us as a guide. If you spend all your time colouring in the cells, we won't get to the programming part.
Does it have to look like a pet?
Well, as long as you recognise it.
Mine is looking pretty shocking right now.
Great. What are you talking about? That's great. Right, there's mine. Hopefully you can see that. So I've got it's got some legs, and it's got a tail, and it's got some ears and a nose.
Oh, tail. That's a good idea.
Yeah, tail's a good idea, right?
Yeah.
Okay, so what I'm going to do underneath it is draw the same one. But what I might do is I might just change some of the features, right? So let me just work out where I did the other one. So I'm going to keep the face in the same place. And I'll probably keep the nose in the same place. But what I might do, here's my body, these ones, is I might move the legs. So I might put a leg here and a leg here and a leg here. Because when we program it, I want it to look like it's walking. And also with the ears, I might move the ears like that, and I might move the tail as well, like that. So they're slightly different. So the tail has moved, and I've just added some more legs down the bottom here. So when we animate it later on, it will look like there's some movement. Okay. And as you can see, I haven't delicately coloured in my cells very well. Lovely. Look at that. Beautiful. Okay. Right. The next step. A beautiful background. Lovely.
I forgot to move the pixels across. It's okay. It's all good. It's all good. I can do it when I program it. It's fine.
Okay, the next step is that we need to label every single one of these boxes, even the ones that we don't have any colours in. Okay, so we're going to use labels that we recognise, and it will all become apparent when we get to the programming part why we're doing this. So this first cell right here at the top, so this is the top left, I'm going to put something in there. That's an empty cell, so I'm going to use the letter E to represent empty. Okay, and all of these are empty, so I'm just going to go ahead and fill them all in as empty. My next row, I have an empty cell, and then this one you can't see very well is pink. So what would be a good label for that cell?
P.
P. Well, that's a great idea. Right, P. And then I have an empty. Empty, 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 empty. Next row, empty. I'm using pink again. So P, empty, empty, pink, empty, empty, empty. Next row, empty, pink. Oh, I've got a different colour. Any suggestions for a label?
T.
T for green?
Yeah, for teal.
Oh, teal. Yes, of course it must be teal.
T. P for pink. Now I've got purple.
V.
Why V?
For violet.
Violet, yeah, right. So the issue here is if I put a P in here for purple and I've got a P for pink, it's the same label but for two different colours. And when we come to programming it, that might be problematic. So I think it's really important to try and use different labels. Okay, so different letters. So having T rather than G, I think is fine. V, I think, is a good idea for violet. Right, so just go ahead and just make sure that in every cell you have a label.
Yeah. Oh, Carrie Anne, your left hand is just in front of the camera. I'm missing a bit of your picture. Oh, yeah, that's cool. That's better. It's just, it must be hard to hold the carry cam at the same time as draw a picture. That's awesome. So could I use PI for pink and PU for purple? Would that would be fine, wouldn't it? Okay.
Yeah, you could do that.
Cool. But then I guess I'd be typing twice as much as I need to, and that would be inefficient.
Exactly, yeah. The whole point of this, and we'll get to it in a minute, the idea is to make your life easier. That's what computers are here to do. That's what programming is here to do. Right.
That's why I love technology. Yeah. Always work smarter, right?
Okay, so do that for both pictures. Okay, I'm going to put my carry cam down and I'm going to switch to my sense hat. Okay, so just make sure those are labelled.
Penny and Isla are joining us from Orkney. Hi, Penny and Isla. Hope you're joining in as well. You probably do much better drawings than I do. Welcome.
Yeah, can you show us your screen, Carrie Anne, again? Just share that back for us quickly so I can see what you're up to. Right. Not that I'm copying you or anything, I promise.
Right, so I should have shared my screen with you. So I've got the Trinket, the Sense Hat emulator that we use via a website called Trinket, and the link I think is up on the screen there for you. So if you head to rpf.io/sense-hat, you'll get to the same page that I'm on. Okay, so if you've made it there, then this is where we're going to type all of our code, okay? And you can see there is already some code pre-populated, and the important one here is the line that says from sense_hat import sense hat. That's importing the modules that we need. And then the next line that we need to write is sense equals sense hat, open close brackets. Okay, so what I've done is I've created a variable called sense, and then I've put what is a little bit more complicated text inside that variable, because it's going to make my life easier later on, right? Because I've got some capital letters there, and Python is very sensitive to capital letters. It's got open close brackets. Like, all of that is a lot for me to keep writing out, so I'm just putting it inside something that's easier for me to write, which is the word sense. Okay,
Cool.
with me?
I am.
Good. Yeah. Right, the next thing we need to do is we need to, all of those labels that we have for our colors, we need now to put them into our program. Okay, so I'm going to start with E for empty, because that was the first one we did. So I'm going to type E equals, because I'm assigning something to it. It's going to be it's a variable. And then I'm going to add the RGB values, the red, green, and blue values for that color pixel. And because it's empty, what it means is, it's really easy to remember. It's 0 for red, comma, 0 for red, green, green, and then 0 for blue. Okay, and I've separated them with commas.
Awesome. So, and they're the same. Sorry, just before we go, those are the RGB values that, like, we use to produce colors on screen and all that sort of stuff, right? It's the same thing that your monitor uses. We're going to be using exactly the same code.
Right, so all the pixels in your monitor and the LEDs that are on the sense hats, they mix these colors together, these three colors, to come up with all the different colors in between. So empty is no color in any of them. The next one we had P for pink. P equals, right, so this is where it gets a bit confusing. What might be the RGB values for pink? Now, the easiest thing we can do to find that out is we can use our good friend, Google. And in the Google search, if you just type RGB color picker, it will pop up with this wonderful embedded color chooser, which if I find pink on the bar down the bottom, and then I select the pink that I'm kind of interested in, you'll see it will give you the RGB color value down the bottom. Super helpful. So if I just copy that, and then if I head back to my Sense Hat project, I can just paste that in and it will give me the color for pink. How great is that?
That is really good.
I love that.
I thought ahead and I made my other color red, which was super easy.
Right, that's a really good point. Right, I'm going to do green. Remember, we gave it the label T, but I'm actually going to do green. So Becky, this is one for you. If I want green, what value might I put in here?
So it goes RGB, so red, green, blue. So I have to do 0, and then the next one's green, so that needs to be on full. So that's 255, or is it 256? I always forget. It's 255. Is it? Yeah.
Yeah.
Woo, I got it right. And then the other one's a 0.
That's right.
Yes. Awesome.
Yeah, so you can game this really well, like Becky has done, and just do red, right? Because it will just be 255, 0, 0. Right, super easy. So my last color was purple. Again, I'm just going to head back and
you could possibly work it out, right? Like, if you were, because purple's red plus blue, right? So my guess would be then that you would have 255, 0, 255. Does that work? Does the math work on that? Would that make purple?
It might do. I mean, it just depends what shade of purple you want.
Sure.
I'm just making my life easier because I'm lazy.
Nice, of course. Yeah, sure. No,
totally. You can totally work it out. And also you can play with these numbers, right? You can make them higher and lower and see what happens. Right, we've got our colors in. The next thing we need to do now is we need to do a code representation of our squares that we have just drawn on our square paper. Okay, so again, I'm going to start with a variable. So this is where you get to name your pet. I'm quite into his dark materials, so I just assume I have a demon at all times. So I'm going to go with Pan. I'm going to call my little guy Pan. Equals, because I want to assign everything that comes after this now to that variable. And I'm going to open a square bracket. And what we're doing is we're creating a list. Okay, that's what square brackets do in Python. And we're going to list every single for every pixel, we're going to list every single color that we want to use in order. So we could write this all out as one line, but with code, what we want to do is we want to make our code readable, so that if there is an error when we run it, which is quite likely because we're only human beings and we make mistakes, we want to be able to spot where that error is. So I'm going to lay my code out in a way that makes sense to me. Okay, so I'm going to press enter so it goes down to a new row. And I'm now going to type out my first row from my drawing. So if you look at my top row, it was all empty, all E's. Okay, so I'm going to type E, comma, space, E, comma, space, E, comma, space. How many of these am I going to have?
8.
8.
That's right. So if we remember, if I go back to my drawing, hopefully you can see it on this screen, but the first row were all E. Okay, so that's that top row that I've just written. So now I'm going to do the next row down. Okay, next row down. The next row was E for empty, E for empty. Then we had pink for my tail.
Yeah.
And then the rest were all empty. Right. So just go ahead and copying what you've written each row by row, separating them all by commas with a space to help you read it. Just go in and put in all of your letters.
And every line must end with a comma, right? You have to make sure there's a comma at the end of your line.
Every line,
I always forget.
Except the last line. You'll see that when I get to it. I'll go over it again.
That's cool. I'm getting tangled up there with myself, and I have to like stop and go back and make sure I've got 8. Like I'm starting to see cross-eyed when I get to like the end of the line sometimes. So
the more simplistic your avatar is, probably the better. The fewer colors you've used, if you've only used 2 colors, this will be much easier as well. It depends how advanced you want to be with it. And my last row is all should be all E's. Now the last letter does not have a comma because we only use the comma to separate between the items in the list. 1, 2, 3, 4, 5, 6. Oh, I've only got 7. I've missed out a row. You can work out where it is.
I'm really excited to see what this looks like when I press run.
Yeah, me too. I think I've got it.
7. I did 7 too.
Yeah, I see. It's easily done. Right, I should have more.
You can almost see it like one of those magic eye pictures when you like stare at the letters long enough. You can kind of get your picture to show up. It's a sailboat. Okay. Should I run it? I want to see my picture.
Okay, well, why don't you give it a go? Before you do, any kind of guesses to what might happen if you hit run? It's always good to try and predict what's going to happen.
I think nothing will happen.
Well, why don't you try it and see what happens?
All right.
I'm going to press run on mine as well so people can see.
Okay. Yeah, no, nothing happened.
Nothing happened. Does anyone know why nothing happened?
I haven't told it to do anything.
We haven't told it to do anything. All we've done so far is we've just assigned lots of variables. We haven't actually done anything with those variables, and nothing's going to happen. So we have to type in the command now. It's going to make our pixels appear on the sense hat pixels. Okay, and that line's super easy. It's just we just write the word sense dot set underscore pixels. And then we call our variable, so the name of our animal or the name of our pet. I called mine Pan, so you can see Pan. So why don't you give that a go now and see what happens?
Woohoo! It's working on mine. Looks appalling, but
I got it.
Appalling, but it works.
Right, pretty cool, right? I've got myself a little pet, and it doesn't look too bad. I mean, the purple or the violet and the pink look a little bit similar, so I might want to change my values at the top, mess around some of those RGB values, maybe to define them a bit more. Maybe I want to add some more colors in there, but this is where you get to experiment and you can try different things, and that's really great. Okay, so we got one picture in there. If I wanted to add my second picture, what would I do?
Copy and paste.
Yeah, actually.
Can I ask any problems with copying and pasting?
Copy and paste it and then change some bits.
Right, it is a good quick step to copy and paste your code and paste it in again, and that's fine. Just paste it and maybe change the ones that need changing. I am someone who likes to type things out several times, so I would probably type it out again following what I've written on my piece of paper, just because I want to make sure I don't get it wrong. But copying and pasting, that works too. So you know, I have pre-written mine already, so I'm going to copy and paste it from where I've already got mine written. So we just do the same thing underneath, but of course this time we need to make sure, oh look, because I used G, look at that, that's your fault, Mark.
Oh, sorry.
Yeah. So this time, the second one, I have named it a different name, because we've got to remember we need to make sure our variables have different names. Otherwise, it will just display the same thing. So let me just go ahead and change all those to be the right labels. And as you can see, this Python development environment is really great because it shows you with the yellow highlighting which parts of your code aren't quite right.
That's really cool.
Right, so I've got my second image in there, which is slightly different to the first one. What do I do to get it to appear on the pixels on the setup?
We need to call it again, but this time we put Pan2, or mine's called Sky, so I put Sky 2.
Yeah, and mine's Pinchy, so I put mine's called Pinchy 1 though. I did Pinchy and Pinchy 1. So as long as I call it the right thing, right? As long as it doesn't have to be 2, as long as I call it the same thing I called it before, it will be fine, right?
Okay. So let's run that. Okay, so I've typed out the same line, sense.set underscore pixels pan2. So what is our prediction of what will happen?
It might be very quick.
Yeah.
It might be very quick. And why might that be?
Because it will be processing, our commands like one after the other, like bam, bam. And so it will not really show us the first picture.
Right, so if I click run, not much has happened. Right, and what we have to understand about the computer is, the computer is a little bit, it's dumb. It's not an intelligent human being that can make assumptions or fill in the gaps, right? So it's trying to process this really, really quickly, and it's kind of a bit confused. So what we need to do in order to see the change between 1 and 2 is we need to use time. Right, we need to put pause in. We need to start thinking about the concept of timings, and so we need to import the module that will help us do time. So at the top, I mean, it doesn't really matter where we put this, but to keep our code nice and readable so that we know where the problems are, I'm going to type from time import sleep.
Cool. And we put all that imports at the top. That's just to make sure that I know they're all there, right? Like that's so I can check them and okay, cool.
Right. It doesn't really matter where this appears. I'm putting all of my code in logical places to me. So my setup code I'm putting at the top. I'm putting all my variable assignments in the middle, and then my code that does the stuff I'm putting down the bottom. And that separation for me makes it easier for me to see where I'm going wrong. Okay. So in between these two, I'm going to put sleep. And then I'm going to put a period of time as a value inside my parentheses. Okay, so I'm gonna put the time, I don't know, 2 or 3 or 5 seconds, whatever it might be.
Cool.
And then I'm just gonna change some of these, because I think what I've done is I've just copied and pasted the same thing.
I was just about to say it looks the same. That's cool.
There we go. And
I think that if I wanted to animate mine, I'm predicting now if we run this code, it's only going to do it once, right? Like it will just show me one and then the other one will stop.
Well, good prediction. Yeah, it's not going to do it once.
how do I get it to go forever?
So I think there what you need to do is to start thinking about using a loop.
Cool. Yes.
Okay, so how many types of loop are there when we're programming?
Iterative loops.
Count controlled loops.
How many, Carrie Anne? You have to tell us.
Well, there's probably more than that, but those are the two big ones. So let's go with those. So we've kind of got infinite loops, loops that go on forever, right? Forever loops. And then we have loops, but in Python we call them for loops. So loops that will go for a set number of times, right? So we could put this code now inside a loop that goes on forever, or we could just put it inside a loop that does it for a set amount of time. So I'm going to use a for loop for this, because I want to be able to do stuff with this code. If we have a forever loop, it will just continue to do the same thing forever, which isn't particularly useful for what I want to do. So I'm going to type for I in range, open, close parentheses. I'm going to put the number of times I want the code to repeat. So I'm going to put 3 and then a colon. And then what I need to do, all the code that I want to repeat, I need to indent it inside. So here you can see I have.
Do you use tabs or spaces?
Yeah, so 2 spaces, or you can, if you use the automatic function, it should auto indent it if you return after the colon. The other thing I need to do is add another sleep at the bottom here, so that it hasn't. Otherwise, it will just go straight back around to the first picture. So to have that nice rhythm, I need to make sure I have 2 sleeps. So if I run that now, you should see my little guy is not going backwards and forwards away. Oh, there it is. Yeah, just 5 is a very long period of time. Let's shorten that period of time. And let's see if we can get it to run again. There we go. So how are you guys doing?
That's cool. I got my little crab guy working.
Yeah, mine's all right. Mine doesn't really look like a pet. It's just pixels moving on the screen. But anyway,
oh, I love the crab.
Oh wow, that's really good.
That's amazing.
I was really impressed with Ali on the chat, who said needs delay time when we were discussing what the problem was that we needed to solve. So well done there.
That's super cool. I'm super proud of my little crab guy. He's really cool.
He's very cool. Okay, so now you've got it working. Now to make it more like a Tamagotchi, what we want to do is use some of the features of the SenseHat, some of the sensors that are on the SenseHat to help us out, right? And so when I'm doing workshops with the actual device, when I have a SenseHat and I'm using it, I like to use the accelerometer. So I say, when I shake it, the pet will walk. I think on here, what would be easier for you guys to see is if we use a temperature sensor. So what happens if it gets really hot? And we can do something funky there. So the first thing I'm going to do is create another set of drawings to represent what my pet looks like when it's hot. And I'm just going to use red for all of the parts of the pet, just for simplicity right now. This will show that I've got a mistake. It's highlighted in yellow because I haven't defined red at the top, but thanks to Becky, we all know what red is now. It's 2550. Okay, so I've got hot now as an option, and what I can do is I can create some conditions to use that, right? So when it gets hot, change my pet in some way. So I'm just going to type my condition, and I'm going to put that condition inside a forever loop. So I want it to just all the time to be checking, is my, just to check the temperature all the time, and then change the picture should that temperature get too high or get too low, right? So I'm going to start with a infinite loop, while true. And remember, capital letters in Python are super important. So you can see here it's a capital letter for true. So let's just make sure we've got that. And then I'm going to set a condition. So to set the condition, I want to say if. Let me just make sure I'm in the right window. If. So if something is happening, do something. And in this case, what I want to do is sense the temperature. So sense.temp. And if it is greater than, let's say 35, because that feels like that would be quite hot in Celsius, then do something, right? So I want it, in this case, to change the pixel, the color of my my little pan to hot. So then I can see when I look at my picture, oh, my pet is too hot. I can tell because it's all red. Okay, and then elif. So if the temperature, so sense.temp, is less than 5, because I think 5 feels, less than 5 degrees feels really cold. Then what I'm going to do is I'm just going to make my pet disappear. So I'm going to type sense.clear, open close parentheses. And then what we can do is an else. So we could just say sense.set underscore pixels. I could just have pan. Okay. Right. So we've created a loop. It's going to keep happening, and inside that loop, what is happening is it's asking a question every time. What's the temperature like right now? And if it is greater than a certain amount, then do something. If it's less than a certain amount, do something. And if it's neither of those things, then do something else. Okay? You with me?
Yeah, I'm just running my code in advance, and I was like, well, it's not working. And then I realised you've got the loop first, haven't you? Doing the loop first, and then it'll do the while true, won't it?
Right. So we might want to do something with this piece of code, right? And what we might want to do is either comment it out so it doesn't happen, or what we could do is we could put it inside a function. So we could define a function for this. So we could call it walking, open and close. And again, we're going to have to indent this code like this. Right, and we could even call that function. So instead of calling this, we could have walking down here. So that's another something else we could do is put all that code inside a function, and then we can just call that function down here. And again, this is a way of kind of refactoring your code. It's like taking chunks of code, putting them inside like a block, and then calling that block later on. It's when you start building lots of layers to your code, and it's just a really nice way to make your code readable for you. But it's kind of doing the same thing.
Amazing. That was amazing, Carrie Anne. That's super cool. Thanks for coming on and helping us out with that today. Really proud of my little crab guy.
The last thing I would say is run your code, and then, at the moment my pet is walking. If you want to change the temperature to see what happens, the sliders are at the top on the emulator. So just slide them along so that the temperature is above 30, 35, and you can see my little guy went hot. If I make it lower than 5 degrees, once he's done his little walk, he should disappear. And so I think it's a great starting point. But the idea of all of these types of projects, and there he goes, disappears because he's too cold, is, whatever you want your pet to go and do now, think about how you would represent that in code. So for example, if you want it to just randomly every now and then kind of tell you need to take it for a walk, you can start using a random function, right? You can start building that in. Maybe you want it to sort of do its little business every now and then. Can you do that? Create a diagram for that and then add it to your code and find a way to make that happen. Can you use the accelerometer to do something with your pet? I think wherever you want to take this should be where you take this next.
Amazing. That's super cool. I love that, the idea that it's like a basic thing, play with the sense hat, get some skills, and then just go and build a crazy machine with the simple bits you've picked up. That's super cool. Again, thanks for coming on, Carrie Anne. That was really great. It was really great to have you today.
Yeah, I hope that was fun. I hope you enjoyed it. I hope everyone here is, who's watching this live stream or watches the recording afterwards, have a go. I would really, dive straight in. If you make mistakes, it doesn't matter. You'll learn as you go along. Just Go where your creativity takes you.
Brilliant. Very cool.
Excellent.
All right, cool. Hope you can come on again sometime in the future, Carrie Anne. But yeah,
Love to.
we'll see you again soon. Take it easy. Catch you later.
Thank you. Bye-bye.
Okay, awesome. So that was really cool. How fun was that, Beck? That was the best fun.
That was really, really good.
Yeah.
Yeah, and I really loved connecting with you all at home as well, and it was great to see so many of you getting involved. Shout out to Al from Andorra and Ali for your help with that delay comment. That was really useful. So great contributions there. Thank you, everyone. It was brilliant.
It was. Thanks, guys. And if you had a really good time doing our Sense Hat session, don't forget to head across to try the AstroPi Mission Zero at rpf.io/mission-0. Whether you want to have another go on the Sense Hat or you're an educator who wants to register your class for the competition, dojo, or your club, go head over there and have a look. It's really cool fun.
Well, that's all we have time for this week, but you can always get in touch with us. Send us an email at dmah@raspberrypi.org, and we'd love to hear from you. And if you're a young digital maker interested in joining the stream, let us know.
Absolutely. We've got another live stream next week, same time, same place. Make sure you subscribe on YouTube at rpf.io/sub so you can get all the notifications and when we're releasing a new video and all the cool stuff coming up on our channel. So thanks for being here this week. Next week, we'll be back with some amazing young sibling inventors, Artash and Arushi. And until then, stay safe and healthy, and we'll see you later. Bye.
Bye.